and welcome to my presentation of the second hand in which I have chosen to work with the billboard assignment. And let's start with the question first, and then we'll just go through the code really briefly. The first question is, what is the problem I need to solve? The problem I need to solve is I have to find a way to make a sign or a texture visible from and give the illusion from every angle. So if we take a look at this, it's a billboard, a commercial for Colgate. Right now we're moving around in the world, but it's kind of difficult to see, but you can see up here that we actually are changing our position, but it always has the front towards our viewpoint. And this solution is really useful because it makes us able to use a 2D plane, a 2D picture, instead of having to create a 3D object. So if you, for instance, have a tree with a lot of branches and leaves and stuff like that, it can save you for a lot of time just by only creating the 3D and 2D instead of 3D. And also it saves a lot of computer power because it doesn't have to work with a 3D object instead of a 2D. So if you have to, in plain words, to explain what the shader code is doing to solve this, we can say that it takes the position of our object here and it translates it, making its x and y coordinates parallel to the camera's x and y axis. And this is done by using the position of the camera viewpoint vertices. And what is this vertex shader doing and why? Well, the vertex shader is basically taking the position of each vertex here and then it's positioning them according to that in the wall space to face the object viewpoint. And the next question is, what is the pixel shader doing and why? Well, we can say that the pixel shader, it actually takes each pixel in the billboard and assigns it a color accordingly to what texture we have applied. And the texture is of course applied by dragging it to our cube up here. Next question is, are multiple passes necessary, and if yes, why? Well, in this assignment, multiple passes is not necessary as we're not working with per pixel lighting. So yeah, we're not gonna talk any more about that. And the next question is not relevant to this assignment either, so we're gonna skip to the last one, which is, what are the uniforms axes and why are they needed? Well, as you're gonna see later in the code, the only uniform we actually access is a uniform variable called sampler2d and then underscore main text, which I'm gonna show you in just a few moments. And this variable is referring to the property above, which is sampler2d, which is a texture. This might be easier when I'm just gonna show you this, and then I'll come back to the uniform that we need. Okay, if we take a look at the actual shading code here, we can see we start out by giving it the name of the shader, and then we're gonna declare the properties. And the reason for doing this is that we want to be able to see it out here in our Unity. If we look at this down here, this actually enables us to use the property that we have just declared. And this is the uniform sampler2d main text. And it makes sure that we can use it in the shader. But back to here, yeah, this is just starting all the code. Down here we have a struct, and this struct actually holds the position of where the object is positioned in the object space. And the next struct we see here, it says, oh, the first one was called vertex input up here, and this one is called vertex output. and outputs from vertex shader to pixel shader, and it decides what's going to happen to every single pixel. So this decides how it's going to look, and this decides the position. This has something to do when we're calculating the new position of the object. And down here we have the code where we're actually going to calculate the new position and also the texture of our object. It's called vertex output vert, and then it uses these. And down here we can see that the output pos, it's gonna be which refers to the struct. It's changed by using mul, and mul is a function in Unity that multiplies. And for the new position of our object, we're using the Unity matrix mv, which is a simple function that we already have to change the position and the matrices of an object. If we look down here, we have this is changing the texture of the object. So if we change one of these numbers, we can actually change the size and where the picture is positioned on the object. For instance, if we change this to 9 or something, we can see it change position. So yes, and then of course in the end of this function we have returns the output, and down here we have as it says, it has something to do with the color. It takes the color from which we have already assigned in main text, and like this, actually without this line it wouldn't be possible for us to actually see the texture on the object. We can just try and do like this and see what happens without that function. And yeah, so we need this in order to take the calculated texture position and add it to the object that we have. And I think that was it, explaining the code and just briefly going through the questions. Thank you for watching.